Good afternoon. This is Andrew Polner with ALP International, welcoming you to the UFT framework, Build or Buy. Thank you for joining us. I'd like to introduce our two speakers for today, Andrew Polner, President and CEO of ALP International, and Patrick Quilter, CEO of Coolmont Solutions. So what are we planning on getting out of this webinar? Well, first of all, we'd like to make sure that you get a good understanding of what an automated framework is and how it should be implemented. Secondly, we want to make sure that you understand the key areas of functionality that a framework needs to have. We'll talk about different approaches to building frameworks. We'll also talk about things that will impact the maintenance of the framework. It's very important that when you build something, you're able to maintain it quickly and have it adapt quickly to the changes in your software. And we'll talk about some resources that are available for you with respect to building and maintaining frameworks. So I'd like to tell you a little bit about how I got involved in framework development. This was back in 1993, which seems like a long, long time ago. And it was a project where a company was migrating a financial application system to a new platform. And there's a group of people involved in the migration process that needed to test the functionality. So we had a test team that really was not all that knowledgeable about the financial aspects of the application, but we did have the analysts who actually were very knowledgeable about how the application worked, but really didn't know about testing techniques and methodology. So what we ended up doing is creating a framework, a very early version of a framework that allowed for us to capture the information from the financial analyst in a way that it could be input and driven against the application, and in that way it was a collaborative effort between the business analysts and the software testers. That particular project worked out pretty well, and that then became a reason to look at implementing frameworks as a standard methodology for other projects as well. Now, typically what happens in automation is there's the initial excitement when there's approval of software testing tools. Everybody in the test team figures that once they get the tools, their life will be made easier. The problem is when you start looking and reading the documentation of those tools, you realize that there's a lot of complexity and functionality that those tools have. Many times you'll find that there's particular functions that appear to do the same thing, and you're left wondering which function should I use, which one's going to be most reliable, and what approach should I take. What happens next often is you try to do something simple to get your feet a little wet with a tool, and you realize that the tool isn't working, or at least it's certainly not working as easily as it was when you saw a demo of it. Later, you end up with a situation where you have written some scripts, but they're not working reliably. So the problem is that every time you're depending on your test automation, you're finding that sometimes you might start the automation and the automation will run perfectly fine, and other times on a Friday afternoon, you'll start the automation, leave the office early, come back on Monday, only to realize that the script stopped working 5 minutes after you left the office. So that can be very frustrating, and building automation in such a way that prevents those things from happening is really what this talk is all about. Now, some individuals have taken the approach of creating very complex automated testing environments. And while complexity in and of itself isn't bad, it's much harder to manage and maintain a complex test automation suite. Some projects in automation are actually even more complex than the software that they're actually looking to test, and that's not a good situation to have. So what happens in the late years of automation on projects? Well, many times the test automation person will be trying to make updates, trying to debug the scripts, trying to make them work, to have them ready for the regression test, only to find out that the project manager already made a determination to release the code. Why does that happen? Because if the automation isn't agile enough and quick enough to adapt to the changes in the application that you're testing, the automation effort is just not going to be relevant. So that doesn't lead to a lot of excitement at that point, and people become disillusioned and often end up moving to other projects. And then what we find is that all the automation that was developed by 1 or 2 people, now those people are not there. Nobody understands what that automation is or how it works, and it becomes abandoned. In conclusion to the introduction, this is something that does happen, and it can happen, and what we're here to do is make sure it doesn't happen to you. So let's talk a little about terminology. Terminology is important in terms of how we communicate things. So the first thing I want to talk about is automation versus testing. We often talk about automation being testing, but automation in and of itself is not testing. Automation is really a process of mechanizing something, of going from a manual process to an automated process. Now we can choose to use that automation for test scripts and test steps, or we can use that automation for things like creating user accounts in a database. So automation in and of itself is not testing. Why do we say that? Because depending on the roles of the individuals, some individuals may be better suited for automation and other individuals may be better suited for testing. In terms of roles, we have business users or functional analysts or SMEs that really understand the business process and the applications and what needs to be tested. But when we come to automation, automation in and of itself is more technical and requires more technical skill. Then we talk about a framework. A framework is a word that's been batted around for many years. And what is a framework? You know, what does a framework, what does it mean to call something a framework? We're going to explore that a little bit. And we'll also talk about the different types of frameworks that are available. Now, if we were to look at the definition of a framework in the dictionary, we'd essentially see that a framework is an essential supporting structure of an object or a basic underlying structure of a system. Now, this is not the definition of a test automation framework, but what's really interesting about the definition is that it's talking about the essential supporting structure. When you read that, you think about like the foundation, the pillars in a building, or the foundation of a house, something that's just immovable, that's going to be there, that's going to support a structure. And when we build automated test frameworks, that's what we need to be thinking about. The basic foundational functions and features that will then support the test automation. So, what is a framework? Is a framework a series of scripts? Or is a framework a collection of utilities? Does a framework refer to a particular type of architecture? Is a framework defined by functions, or the fact that those functions are in libraries? Those are the things that we'll be exploring. Let's talk about three types of automated frameworks. There's data-driven, keyword-driven, and process-driven. So if we look at data-driven, that's the most basic type of automated framework, and it's the least complex to implement. So the data-driven framework combines both static and dynamic elements. Because of that, there's a high degree of maintenance required. So let's look at a typical script and how we would make it data-driven. So you'll see on the left-hand side of the window, there's the original test script, which navigates through an application, and it has some hard-coded values for the client number and the order number. So what we do is, to make it data-driven, we simply change those hard-coded values that are captured in the application with variables. Once we do that, we can take the same script, and now we can have not just one, but 7 different test cases, each with a different customer number and an order number, and each of those now represents a different instance of a test that we're testing reusing that same script. Now, the data-driven automation essentially reuses the path that we used in recording. We've done that substitution, and it makes it easy with that substitution of values with variables to create additional data sets. Now, the problem with this approach is that it's very inflexible, in that for every test that you have, you're basically creating a test and a data set, a test and a data set. So while that might work for a simple application, for most applications that we have and that we test, that would easily spin out of control and be very difficult to manage. So next up, we have the keyword-driven script. Now, in the keyword-driven script, we basically have an interface that's very business user friendly, where you don't see the code when you're defining your test scripts. What you see are the different parameters that need to be specified for your test case. Now in this case, we have an action to either buy or sell a security. We have the ticker symbol for that security, and then we define the quantity to buy or sell at the price point indicated. Now from a business standpoint, it's very easy to define a test case in this way, because there's no coding that you think about. However, behind the scenes, there has to be code that then interprets the information from these keywords and does something with them. So that might look something like this, where you have a buy-sell test script, and based on the action, buy or sell, it'll go to a specific part of the application and set the window control to that action, and then based on what security we're buying or selling at what price and what quantity, it'll actually set those fields and do that magic for you. Now if we look at the keyword-driven framework, from a complexity standpoint, it's a little more complex to implement, because we have the nice user interface, but we have more coding and more logic that needs to be put in on the back end. It does have a nice degree of encapsulation. That means kind of a separation of the data from the code. And it's very easy, as we already observed, to develop your test scripts, because it's really all based on keywords and data. From a maintenance perspective, it takes a little more effort, and from an auditability standpoint, we rate it low. Now, what does auditability mean? Auditability is the ability to know whether or not the automation actually did what it was intended to do. It's fine if you run a test and everything reports as passing, but what if something actually didn't pass and the automation itself didn't report that? With a keyword-driven framework, it's a little more difficult to know and to understand whether or not something actually passed or not. So now let's move on to the process-driven script. Now, a process-driven script is similar to keyword-driven script, but it has a little more structure in terms of how it's organized. So we have, in this case, in this particular example implementation, we have 4 columns. So the first column is your window or your screen. The second column is your object or your control. The third column is the mode. And the fourth column is the data. So you see, in the first line, we're going to the window, that's the login window. And then from there, we are selecting an object named name, where we input the person's name. We do that with a password, and then we do that with an OK button. Now, the following sequence below shows us that we go to the login screen, but this time we're actually looking for an attribute. So we go to the name field again. This time we're looking for the focus attribute, and we're checking for the focus attribute to be on. So now we're doing validation in the same very simple and concise format. Now, the process-driven framework is the most complex to actually develop, but in doing so, you end up with something that's incredibly flexible, because now everything is defined outside of the code itself. All your instructions, all your processes, etc. It has a high degree of abstraction and encapsulation, and the idea behind the process-driven framework is to have purpose-built functions that require the least amount of code rewrite. It's low in maintenance, and it's high in auditability. Why? Because we can actually see what is actually going on in the script very clearly. Now, if we were to compare the 3 approaches that we just discussed, data-driven, keyword-driven, and process-driven, like with anything else, they each have advantages and disadvantages. So as I mentioned, with the process-driven, although we have a lot of flexibility, there's also a lot of complexity to get it off the ground. With data-driven, it's very easy to create a new script, but to maintain it, it can be quite cumbersome. So this table looks at the different characteristics, from adding new scripts to the need for the maintenance of the code, the ease of which code updates can be made, the impact of those updates, etc. It nicely sums up these different characteristics. Now let's talk about attributes that a framework should have. So the first aspect of a framework needs to be reusability. We build frameworks so that we can reuse them time and time again on the same application for subsequent releases, for changes in our infrastructure, etc. We need the framework to be flexible. because when we build a framework, we don't want just a few select people that are very technical to be using it. We want the whole team, the whole test team, maybe even some business analysts to be involved. We need to be maintainable so that every time there is a change to our application, and there will be because that's why we test, that we're able to very quickly understand what part of the framework needs to be updated and how to best update that. It needs to be scalable. And what does that mean? Well, often when I talk to people about automation, I'll ask them, how many automated tests have you built? And they'll say, oh, a dozen, 2 dozen. And the problem is that most applications, even of medium complexity, will typically need hundreds, if not thousands, of scripts to properly verify those applications. When you have automation, you need to be able to have an environment that scales into the hundreds or thousands of scripts. If it's not able to do that, then it's really not going to be a great solution for you to just have a few dozen automated scripts. Adaptability. You need to be able to adapt to future needs in your testing. Once you start using automation, you'll find that there's other things that you need to do, and automation should be able to be used for those. And finally, extensibility. So extensibility would mean, let's say that currently your application has a calendar widget, and that allows the user to select the date on the calendar. And what happens if the developers in a new release decide that they're going to use a different third-party control to render those calendar widgets? Now, all of a sudden, we need to make sure that your framework is set up in such a way that that new third-party control can be made to work within the automated framework. So the framework needs to be structured in a way that you basically can just change out the code that deals with calendar widgets so that your new code now will deal with all the new calendar widgets from the new third-party control. Now, I'm going to digress a little bit here and talk a little bit about ASTQB and ISTQB tester career roadmap. This is not an error slide. The reason why I'm bringing this up is many of you on the call are familiar with ISTQB and ASTQB, and what I want to alert you of is that there's a new syllabus that was recently put into publication that I'm highlighting at the bottom of the screen. It's called the ISTQB Test Automation Engineer Syllabus. Now, this is not about how to use a particular tool to build test automation. It's all about best practices and architecting an automated solution. To give you an example, Chapter 3 of this syllabus, which is called the Test Automation Engineer Syllabus, Chapter 3 talks about what we refer to as the generic test automation architecture. And this is an architecture which is nicely summed up by this image. And the image is basically showing us, if we look from the very bottom, we have a test adaptation layer that defines what types of interfaces we're testing against. Is it a GUI application, a services-based application? Are we doing testing directly against the database? Next up is the test execution layer. That's what we normally think of as our automated testing tools such as UFT and others. Up from there, we have the test definition layer, the test conditions, test cases, and the data. And at the highest level, we have the test generation layer, where test models actually create the overall information, processes, and data for your testing. So this is a very small part of this particular syllabus, but it helps provide guidance on how to build proper automation and what the architecture should look like. Now let's get to the essential functionality of what a framework needs to have. And soon we'll be doing the actual demonstrations, and you'll realize how all this is so relevant to actually implementing a framework in UFT. So the essential functionality needs to include inputs, navigation, synchronization, and validation. Now by inputs, we're talking about not only entering data into an edit field, but we're also talking about selecting from a drop-down list, or clicking on a link, or selecting from a calendar. With navigation, we're talking about how do we get from point A to point B in our application. Is it by clicking on a link? Is it by, tabbing? Any number of ways of how we get from point A to point B in our application. Then synchronization is making sure that we synchronize as we're going through the application. And are we synchronizing on an image or actual text showing up on the screen? Or is it a particular attribute, whether or not an object is visible or not? And at what level should the synchronization occur? And finally, the validation. How do we validate? Are we validating text or attributes? Now, often when we talk about synchronization and validation, it sounds like we're talking about the same thing. But it really isn't. Synchronization is really making sure that you're at the right place in your application. And often, automation fails when we don't have synchronization implemented correctly. And that's what we call that runaway behavior, where the application either hasn't shown the screen that we're expecting and the actual automated script keeps on running along because it's not waiting for it, or the opposite can happen where the automation itself gets stuck and cannot proceed. So this is a good way to think of the difference between synchronization and validation. Now, when we look at objects or controls, every object, regardless of what platform we're on, has specific attributes. Now, many of the attributes are very similar across objects, but also each object will likely have some unique attributes. So a common object might be a button or an input or a select or a text area object. And then the attributes for these could include things like autofocus or disabled, meaning, check for whether or not this object is enabled or not. You might need to know the name of that object if it's a required object, or what the value that the object is currently holding. In terms of functions, we basically have different functions that need to be built to support those object interactions. So we want to have a function for inputs. We want to have a function for validation and one for interrogation. Okay, that gives us a primer in a sense of what we're talking about with automated frameworks from a very high level down to the object level. Now I'm going to pass control over to Pat. Pat will actually demonstrate frameworks and go into a little more detail of implementation tips and tricks on creating the frameworks. Pat?
All right, thank you, Andrew. And before I start, can you just confirm that you can see my screen?
Yes, thank you.
Excellent. Hello, everybody. Good to be with you today, and special thank you to Andrew for including us in this webinar. As he mentioned in the beginning, I am the owner of Quomont, and glad to be here to share some of the experiences and knowledge that we have on this topic of framework development. So we're going to look at what putting together a framework in UFT looks like. First, I'd like to show you basically building a keyword-driven framework from scratch and what's involved there. And then we'll get an opportunity to look at a framework kind of in the genre of process-driven that Andrew was talking about earlier, something our company has been developing and maintaining for a long time. So you'll get a chance here to see what it's like to create something from scratch, and then something that's kind of pre-made, meant to be brought into an organization so that people can get started with development right away. All right, so first of all, let's start from the top here, what we're looking at. First thing I'd like to point out is the concept of object mapping in UFT. So UFT has what's called an object repository, and you'll see I have some entries in here already. And all we're trying to demonstrate here is that we have a very small repository, very small amount of objects in it right now, and they just map to this initial login screen. So the way to look at this is that each page or window, if you will, is represented by this login tree entry here. Okay, that talks about the entire window here. And then something like the agent name and the password map to the individual text boxes that are right here. So this is the part that actually causes the handshake between when UFT is executing a script and it actually putting data into an application. And it's really these properties right here, these descriptive properties. This is what tells UFT how to identify a particular object in this window. Okay, so that's the first part to understand about the object mapping. So as I mentioned, our task here is to build a UFT framework from scratch. So one of the things that we can use that's, if you don't know, UFT leverages VBScript. So VBScript has what's called a dictionary object. And what that basically lets us do is associate key item pairs. So what I'm doing in this example here is I have some static representation that makes up my key. And I'm going to dynamically populate the items that are associated with those keys during runtime. And where am I getting that data from? That's what this data table here is doing down at the bottom. So even if you don't understand coding per se, you can start to make some relations between the column names here. So I have a page here and what we're doing with the dictionary object up here. So each time you're seeing page, object, value, keyword, these are really my columns that are in my data table right now. And when I say I'm populating data dynamically, that's when I'm starting to talk about the individual rows that are here. So every time I go through here, if I was going to execute these steps manually, I'm basically saying, let's fill in the agent name with the value trainer, password with Mercury, and then we're going to click on that, the OK button that's on the application. These values get processed one at a time, one row at a time, and that's what dynamically changes these values right here during runtime. And that's essentially the whole idea of the dictionary object. I have keys, and I'm going to have different data going through and assigned to those keys so that I can take different actions with them. The next thing to point out here is that we need a little bit of knowledge about programming and specifically doing condition statements. And in some cases, although we don't see it here on the screen, how to control looping. So with our condition statement here, what we're trying to do is every time we go through one row, we're trying to read the keyword, the name of the keyword, what we're calling enter data here, and checking to see if we're on a row that contains enter data. If we are, we're going to use our dictionary object to say, identify the page that we want, or the window we want to communicate with, and find the object value we want to communicate with, and then put that value in there. And this is all contained within that dictionary object. So what I wanted to leave here on lines 15 and 16 is what this looks like when it's not in the format that I have it here, not in this dictionary object format. So we're just using something that might have just come with when we did a recording session and what it looks like to fill out that object. So notice here we're explicitly saying we want to reference the login window. We're explicitly saying we want to reference the agent name. We're doing a command of set, and then here's our value that's coming through. And what's interesting is on line 16, it's the exact same format, right? Everything all the way up. The only thing that's changed here is that we're talking to a different object and we're putting in a different value. So that's why the light bulb should go on and say, hey, we can make our code, even though it was nice that this information was recorded for us, if we started combining these things, we can make our code very succinct. We can make it very repeatable and reusable and easier to maintain. So that's why line number 17 is important, and why it's important to make these things more dynamically driven, because now I have a function or I have a keyword that can be used for any Win edit or text or data entry box that I might want to communicate with. I can reuse this line of code over and over again, and all I have to do is pass in these 4 values, page, object value, and keyword, to make this all work. Okay, so in continuing with that, we made one additional keyword, which was click, so that when we get down to line number 3, we're no longer entering data over here. We want to identify the window, the object, and then perform a clicking action on it. So same idea, but we're just breaking out our keywords. So in order to enter information into that login box, that's all we needed was two individual keywords. So that went quickly, but hopefully you saw that. We flashed in there and we entered those 2 values and clicked the button, and we actually logged into the application. So that's great. But just to point out again, in order to get to this point, and this was the simple stuff. This is meant to be, we're starting from scratch. This is probably in the hands of one UFT developer. They're starting to think about architecture. They're starting to think about where the long-term goal is when developing this type of a keyword structure. At some point, they're probably going to want to centralize this data table. Right now, this is just right inside of the data table that UFT provides, but there's certainly ways to get it in Excel, export it out of here, let other teammates, other testers, analysts put in that data to make up a test case, and then that gets imported into here. So that's going to be a logical step that eventually the developer is going to need to take. Certainly, we're only talking about 2 keywords here. There's going to be a need for many different keywords. So this list this structure will stay the same. We'll keep adding to our condition statement here, but over time we're going to have more complexity. It's going to get bigger. And then, of course, back to the object management information, we have to maintain that if the application changes. The good thing is that we'll make a shared object repository out of this and be able to update that in one spot if the application ever changes, and then all of our test cases pick up the change. But just keep in mind that these are the hats that you have to be wearing when you're architecting a solution like this. So you don't just snap your fingers and this stuff comes together. You have to understand object mapping and architecture. You have to understand coding. You have to understand things like the dictionary object. Now, an alternative to this, if you didn't want to build something from scratch, is to leverage an existing framework. So let's take a look at what that looks like. Okay, so over here we have our framework, and the way that we break things down, and actually let me pull up the application that we're going to be executing against. Okay, it's our good old Mercury Tours web application. Okay, so first thing to note here is that we separate everything by projects. Now, our keyword-driven framework is meant to be repeatable code. So hopefully by now we can start to understand what that means. We're developing and parameterizing very specific pieces of that UFT string, and then that's what makes things portable. So we can then start to think about breaking down the application into individual projects. So every time I have a new application in our framework here, which we call TCM, Test Case Manager, it's an individual project. When I go into an individual project, I have 3 control panels that I can go into, but we're going to look at application and test case, and let's start with application. And I'm going to start with edit objects. So essentially what this is an entire table that holds all the object information about the application we're testing, so our Mercury Tours application. Okay, all the objects that are present on this screen right here are in our table. and we have what we're calling the object description as one of our columns. And this leverages something that UFT and QTP, the previous version of UFT, have supported for a long time, and it's called descriptive programming. So we're able to take the descriptive programming. This is in lieu of what we saw in the object repository. This is another way UFT can identify object information that's on the screen, essentially bypassing the object repository altogether. Okay, so we list the object description in the column, we list the page or capture what page this object is on, and then we give it a user-friendly name, and we'll see why that's important in a little while. But essentially this table gets populated with all the object information, and then we can start thinking about creating test cases. Okay, now you may say, hey, that looks like a lot of work even to get all the objects mapped out correctly. Do we have to type all those things? And we don't. That's what this Learn Object button will do here. It automatically opens up the page and goes through and scans the page for all the objects and all the object properties and populates that table for us. So I've already done that, and we can see that at another time. But that's essentially how we do our first pass of getting all the objects that we want into our database and into our framework. And it's a one-time thing. We only have to do it once per application. The next place that we would go after we've done that spot is we can actually start creating our test cases. So every time I create a test case, it's a new entry in our drop-down here. So let's take a look at one that I've already created. We're calling it Register User Test Case. Okay, so the data that populates is a series of steps that I have put in already, and I'm able to do this by selecting a drop-down when I'm in the application page, and I'm telling, I'm building out my instruction set here. So the first thing that I can do is pick a page that I'm on. And then after that, after I select the page, it then only shows me the objects that are associated with the home page in this case. And then I can pick a keyword. These are pre-programmed keywords. This is the part that eventually touches code. On my UFT side, I have code written out that handles what a web sync object is supposed to do, what the web enter data is supposed to do. And then if we follow this structure all the way down to the bottom, we'll see at the end we do a verification point, which just checks to see if a particular object exists when we get to that page. And then, of course, any of the values that I need to provide here. So when I register a new user, what I'm doing is synchronizing to make sure I'm on the page that I want to be on. I enter some data by doing a click. And then I get down to the actual registration page where I fill out basically profile information. Okay, so that's what the test case looks like in the instruction set format. The whole reason for filling out that object table in the beginning is so that we can get some ability here just to pick a page that we want to be on, and then the object that we want to communicate with, and then fill out the rest of this per the keywords and provide the data that's needed. So let's see what this looks like when we run it. Okay, a lot of our framework is pre-configured into UFT already, so you won't see a lot of scripting because of the way we have architected this together, so that it calls all the code that needs to be called and in the right order. And first thing that the framework is set up to do is close all existing browsers so that they don't interfere or they're not there from a previous test run. And then it's going to pull the data that I've specified. So I put in that run register user test case, so it's specifically going after that. And it's going to pull back the data that I had entered and open up the application and start putting the data on the screen. Okay, so in something like our framework, that's how we would create our initial test case. From there, we would make a copy of that test case and give it a new name. Okay, so now it becomes part of our drop down here. And a lot of times your test cases have the same path, and it's just a matter of changing the data. So I might want to change the name for this one and several other data points here, and now I have a second test case. The other important thing to note is that once we start getting up a big suite of test cases, let's say we start getting into the hundreds, we certainly don't want to have to execute these test cases one at a time. So that's when we can take I called it architecture before, but essentially the way that we set up our ability to call a centralized code base and move that into Quality Center ALM and be able to run these test cases in batch so that we get more, we can run 100 at once and maybe do some lab management, run 5 at a time, and so on and so forth. But that's essentially the direction that we can take it very easily by pulling in this particular framework into something like Quality Center ALM. To finish up here, let's just take a quick peek at that report. The information that we get on the UFT side, you can see where we have the steps along the way, all the things that we did during that individual run. You can look at this report and figure out what the steps actually did. If there's any failures, obviously we would drill down on that, and then of course we get a screenshot here. Okay, so that's what it looks like from the UFT perspective. This is took a significant amount of time to get to this point, but the things we like about it is that we can set this up quickly and we can get multiple people involved in the test automation practice, actually get them contributing right away, right when we start a project, because we have all these things already in place. And then it's a matter of filling out data because we have things so abstracted here. Last thing I want to point out is somewhat of a neat little trick here. This came up as a need when we were working on some mobile testing. The project that we were on had an application that you access from the desktop, and there was also a need to test that same application on a mobile device. So the tool that we ended up implementing was Selenium. The automation engine that we tied into the TCM process. And if I was going to take our exact same test case that we just ran right here, and I wanted it to work with Selenium, I could do that very easily by making a few changes. First, I would go to my where I'm maintaining all of the object information. And what you see here that looks different than, we don't see the browser page in image anymore. What I did here was just simply change it to a syntax that Selenium understands and expects. Okay, so I changed the objects of that particular test case I wasn't going to spend all day updating the entire thing, but just because I wanted to see how quickly we could turn this into a Selenium test case, that's all I needed to do. So that's why these things are a little bit different here. But it's just a matter of changing the object description here and then coding the enter data and the click and the exist keywords that were in VB script, because that was running in UFT, and changing that into Java format. And one of the nice things about Java that you can do, because Selenium is it's more difficult to implement than UFT. It's just a completely different set of skills when working with Java programming. There's library configurations, there's things you have to download and set up a whole environment. But the nice thing is, once you get it to a good point, you can export it into this executable that I have right here. So I have a TCM executable. It has all the Selenium compiled into it, and at this point it's just a matter of clicking it to get it to run. I could also move this into something like a CI/CD environment, or I can invoke this jar file, this executable file, from any interface that I might want to use. And so it's pretty convenient to be able to do that. Now, one of the things that we ended up building into our Selenium version here is that if I was debugging this script, so I did my development in TCM and I'm ready to actually run it and I want to see what it does, I can have it prompt me and show me a list of all the test cases that are currently inside of TCM, so I can pick it right from here and watch it run. So we said we were going to run, yes, this register user test case. So let's select that and hit OK. And now here's my test case again, pretty much reusing the entire instruction set from the test case perspective. And I was able to change the automation tool because of the level of abstraction that we have with this framework. So think about the possibilities here. Today we're talking about UFT and Selenium. What's the next great thing that comes down the pike? And if we want to leverage that, is there a way of us avoiding having to do a whole bunch of rework to get it into that next new tool? And with this strategy, there is. We can strategically change things in a few spots, and now we're up and running again. Finish with a little report here, that a generic report that just gives us the step breakdown of everything the Selenium test case did. All right, well, that sums up the demo, and I am going to turn this back over to Andrew in a second, unless he can just take it, and it looks like he has. All right, Andrew, I can see your PowerPoint, and I'm going to go on mute.
Okay, thank you, Pat. That was very helpful, and as Pat mentioned, there are a number of preconditions that need to be coded into the framework, such as closing browsers, and then there may be post conditions like moving files out of directories. So a framework needs to really have a lot of functionality, not only to run the test, but to do the pre and post cleanup. It has to have the reporting and the logging capability so you know what exactly happened, and it has to have some error handling. Now, test objects, in terms of success strategies, you really want to make sure that your framework is abstracted. You want to have the right roles, the people with the right skills, whether it's VB script or Java or whatever programming language skills they need to have. And you really need to focus on data. Data is really key to automation. The tests themselves need to have a singular focus. You have to have all the data that we talked about in terms of navigation and synchronization and validation, and be careful about using application logic in your framework, because that adds complexity to your framework, and you're basically trying to replicate what your application that you're testing is already doing. So abstraction is very key to building the right kind of framework. And with abstraction, you get that reusability of components. Abstraction allows people that are not technical to be a part of the process because they can define data and data flows. And abstraction also then allows people to be defining tests in advance because they can actually define the data for the application that's forthcoming, saving you time. And by having an abstracted framework, the maintenance requirements will be much less, and you'll be able to adapt it to future technology. So, some final thoughts. Yes, framework development is possible. You really need to find a framework approach and the technology that's going to be commensurate with a technical skill in your organization. If not, there are external resources that you want to help you to avoid the missteps that can be common, and the old adage about walk before you run. Do a pilot, make sure it's successful, you get the buy-in, and you go from there. Finally, in terms of some resources, this webinar is being recorded, so you'll be able to view it again for anything that you may have missed. We do offer the UFT training if you're interested in getting trained on the basics of how to use UFT. And we've just announced the UFT Framework Workshop, which is now posted on our website. We also have UFT implementation services where we actually go in and help organizations with the coding and the frameworks that they may already be working on and help them get to the next level. We have the implementation solution, which is a complete solution that can be customized to your environment. That was TCM that Pat showed at the end. And finally, we have the resources of the advanced level test automation syllabus, which talks to the different ways in which you architect your automated framework. We will soon be announcing a ALPI advanced level test automation certification training, probably toward the end of the year. So that'll be yet another thing that you can look to us for. We have a few minutes here for some questions. So please, if you have any questions, go ahead and submit them through the chat window. And let's see, we do have a question. How long does it typically take to implement an automated framework? Pat, do you want to take that?
Yeah, sure. Looking back on past experiences, the reality is it could take up to 3 to 6 months, I would say, to get it solid. Now, it's a phased type of development, and that's why I would say it kind of takes that long. I would say what typically happens from speaking from the engineer's point of view, a lot of your responsibility, what falls on you, is actually testing the application. And then when there's strategic times in the development lifecycle, you might start working on the automation and getting it ready and trying to get it ready to go for the next iteration of when you're actually going to have to do testing. But reality is we get distracted, we get pulled into different directions, different priorities come up, and it drags a little bit. So there has to be a commitment in order to kind of manage that time to get it where it needs to be. Remember, the application is constantly changing, so sometimes it takes a little while for people to figure out how to actually get a grip and make the automation meaningful, and then also work with their management team to negotiate enough time of when to work on it. So if you factor all of those things in, it could take up to 3 to 6 months to reach a real robust, solid point.
Thanks, Pat. Another question came in, why the UFT framework is built on object repositories?
Yeah, I can take a stab at that. So why is it, assuming that means why is an object repository used in UFT? Well, I would say the biggest benefit, we didn't get to see that in the example that I went through, is that taking the repository and going through the same approach of filling it up with every object that you could possibly find in your application, and then having the ability to centralize that is a huge step forward, because as you start to bring more engineers, automation engineers onto your team that are testing that same application, the team can keep one copy of the repository. Okay, that's what's called the shared object repository. And then from there, you can, if something breaks, your team member can update it. Once they update it, you pick up the change automatically. So it's an important strategy to, number one, be able to have one copy of something that everybody can use. That saves a lot of time. And number two, there's a lot of decent user-friendly features built into the UFT object repository that make the object maintenance a little bit quicker. So I think back again to the bullet point there you had about the course. There's not enough to say on this, not enough time to say these things on the webinar, but I'm sure certainly go over that stuff quite a bit in the coursework.
Thanks, Pat, and that'll be the last word. We thank you for attending. Thank you for your insightful questions. We hope it was a good learning experience for you to really get your head around frameworks and implementing a framework with UFT. We look forward to hearing from you with any follow-up questions. And thank you again. Have a good day.